Then for our talk tonight, we have Christoph here, who's also working at Object Bay, and he will be talking about how to turn PostgreSQL into an event store with Marten. Please give a big round of applause for speaker from tonight.
Hello, everybody. My name is Christoph. I'm working at Object Bay as a software engineer. And today I want to try to introduce you to Marten. It's a library for .NET. Of course, the microphone needs to be turned on. It's a library for .NET, and it turns kind of Postgres into an event store. And I hope we get to this point that you get a little bit more familiar with it, with the concept of event sourcing and with the concept of an event store and how we can do it with Marten. And yeah. All right, so that's the logo from Marten. But I don't really like bright screens, so I switched to dark mode. And maybe you're familiar, and I guess most of you are, with this awesome tool, EF Core. I think we all agree that it's really an awesome tool, and we all love it. It makes our lives more easy in interaction with databases. It's an awesome OR mapper. And once you are familiar with it, I think you also are familiar with this kind of folder. So it gets really big. It's a screenshot from the internet. It's not mine. And it's from 2013. But already when we look down there, it's only 1.5 months. And it really grows really fast. And why is that actually happening? So if you can see the screen, it's not so dramatic. Just explain it. So this should be a mock-up of a registration screen. And so we try to get to know why we have to do migrations because of requirements. So we have the registration screen, and once the button for registration gets clicked, some action should happen. Actually, the user should get registered with its name, with its email, and its password. So good. After some time, usually requirements changes, business is talking to us, oh, maybe the registration screen is not enough. We also need to have a one-time password to verify the email. And we also get some new screens. We have an email verification emailer service. And once such an email is sent to the person who wants to register, we expect to have a new kind of action. Verification email was sent to somebody with a certain email code. And maybe in your head you were already figuring out, okay, there maybe needs to be a table with a user. It has certain properties, ID, name, email, and a password hash. But it's actually not enough. Because of our new requirement, we also have to introduce a new column, which is called code, because we need to send the verification code to our client. So it's a very simplistic example in how we have to extend our tables. All right. So maybe, so let's focus a little bit on the language that we have to use we as technical experts are talking. We usually use complicated technical terms. We love them because they sound very intelligent and very awesome. But there is a second group of people, I would say. They are called domain experts. So they actually know how the business works. And they also like to use domain terms. And that's then our problem because maybe we don't understand them fully. So there is kind of the same problem. And if we have a look into domain-driven design, so it's a concept from there. It's not about domain-driven design here explicitly, but the idea of a ubiquitous language. So we kind of create a shared language. We agree to use terms from the domain and to use those terms everywhere. For example, in documents, in documentation, in our code, and also when we speak to the business. So there should be less confusing stuff. But that's not all, because we also can think. And domain experts, they think and also communicate in processes. So we saw it in the last example, maybe from the perspective from a domain expert to say, we need to have a registration screen and the user has to register, and then we need to send a verification code. And we as a technical persons, we maybe were already thinking in CRUD. So it's quite obvious. So it's pretty far from each other. And after the meeting, we usually think, okay, what they were talking about. And both parties are thinking the same. So maybe the domain experts are confused and we as technical people. So what actually, and I love this quote because actually what gets deployed, I hope you can read it, I will read it for you. It's developers' misunderstanding, and that's released in production, not the experts' knowledge. So what we understand gets released into production. And let's focus a little bit on CRUD. So why do we actually think in CRUD? I think we are trained a lot to, or forced to think in this kind of, to think in CRUD, because the technology we are using is also very CRUD-centric. If we have to have a look at databases or REST APIs, which is kind of our daily work or daily routine, it supports it because we're using those words. We use create, read, update, delete for databases. It's all we can do with it for interaction. And on the other hand, there are REST endpoints, which is post, get, put, delete. And if we implement real REST, we can map it to CRUD. So we are kind of trained because all the important interfaces down to the database and down to when we expose functionality is CRUD-centric, I would say. But the language of the business is processes. So they communicate in another way with us. And of course, there needs to be some transformation. So maybe you did it already in your head with the email verification example. You thought of how can we put it all into a database structure, into tables. And let's figure out if we can do something else. So now we are switching into another example, and we will stick with this example for the rest of the talk. So it's about banking. So we consider a bank account, and when the business is talking to us, they usually say, okay, we want to open a bank account, we want to deposit money, and we want to withdraw money from the bank account. So that's actually the language from the bank account. And it's the intent, so we can call it, they want to achieve something. Of course, it's a very simplistic example, but maybe you can relate it to your domain. So it's a business intent, and if we map it to just CRUD, it's only create a bank account, update the balance 3 times, because we only have update. And yeah, so a lot of information is lost, and we are actually only maintaining the current state. So we only need know for each point in time what the actual balance for this bank account is. So what if we can do better, and we can just instead of using our CRUD thinking what if we can map it to some other stuff? And this other stuff is we can translate it into facts. So when the business intent is to open a bank account, then the fact is bank account opened. When we deposit money, then money was deposited. When somebody wants to withdraw money, then money is withdrawn. So now we can translate it into some kind of facts that actually had happened. And that's already the idea of event sourcing. So we don't update the current state. Instead, we save facts that happened. Yeah. So when we think about the past, we cannot change the past. Facts that had happened are immutable facts, so to say. And the second idea of event sourcing is just to append those events. And once we append events, so the orange boxes we consider to be events, they are just expressed in past because they already had happened. So in the term, so this is just some terms of event sourcing. The orange boxes are called events. And when we consider the whole events for a certain bank account, for example, it's called an event stream. But there is actually more, because when we stack all those events together, we can reconstruct, of course, the current state. Because of each fact that happened in the past, we can say, okay, the current state is bank account of John has now a balance of 75 because of his events he did in the past. So this is actually called the aggregate. We aggregate all events into the aggregate, and we can know the current state. But there is more. When we have all events from the past, why not just calculate something new that we didn't know that we have interest in the future? So maybe we want to know some statistics and want to analyze how often John was depositing money or withdrawing money. And so we can just calculate it from the events that happened in the past. And that's called a projection. And maybe now you think, okay, what's the difference of an aggregate and a projection? And there is a significant difference, because on an aggregate, we use it to execute business rules. So maybe the balance is already 0 and the business rule says, okay, you cannot go below 0, so the next event gets discarded. And the projection is just some data maybe to ship it to the front end or another client. So it's just a read model. So we already can prepare some data for specific use cases and just provide it to our clients. All right, now let's go to Marten. Some facts about Marten. It's already a major library. It's created 2015. It's open source and MIT license, so we can use it in commercial applications for free. It's on top of Postgres. So, yeah. It just sits in the middle of our app and Postgres, and it kind of turns it into a document store and an event store, and we will see what this means in just a few minutes. It has a really good documentation, so it's well documented and maintained. It's a bit opinionated, and we will get to it why. It offers and actually combines the possibilities of a document store and an event store. And if you're wondering what is a document store, it's usually no SQL, so MongoDB, for example. So we just save JSON documents. And that's already what Marten heavily uses. It's the support of the JSON-B. That's a JSON-B support of Postgres, so it serializes our objects into JSON and saves it. It handles migrations for us, so we don't have this huge folder. And just for your information, it's actually version 8 right now. Just want to highlight that it's actively under development. Just some words or maybe some concepts of Marten. We have the document store. So we need to so the document store is actually a class. We are going to see it in a minute. And it's just the configuration for how we use Postgres and how we can connect to Postgres. We have some kind of unit of work sessions, so we can use it like DB context. So the ideas are quite familiar to us. And the implementation also, we have an iDocument session, which allows us to read and to write. And we have an iQuery session, which actually can be only used for read-only operations. Then save changes async for executing transactions, and it also offers link support. Okay, so let's get into a demo. I hope everybody can read it, maybe from the backside, a confirmation. Okay, thank you. All right, so just short, high-level overview. It's just some tests. So I used TUnit to execute the tests. I will show you a nice concept from there. And we are just using the bank account example from before. And we are going to first have a look at the document store. All right. So as I said before, when we can use the document store class to configure our Postgres database and Marten, how it's interacting with it, we need to provide the connection string. And actually, that's already most of it. we can declare a schema. And I used many schemas for all the different tests, so I can better show you what's going on. So once we have the store or the connection to the store, we can open a lightweight session. And the lightweight session just means you can imagine like the change tracker of EF core. So we don't have actually an change tracker here. So that's the lightweight session. We also can use another session, but in most cases it's not needed. Why? Because when we do event sourcing, we don't actually update our records because it's an append-only log. So we only append stuff. All right. So in this case, we just create a bank account object. John Doe has $1,000. We can use the store method. Just call save changes, and it should be saved. And I will just place the debugger here. To see what's actually going on. And I'm switching between data grip and writer just to show, okay, what's going on in the database. And here we have the first schema, and it already contains 5 tables. So that's what Marten did for us. And but we are interested in only one table now, actually. We are interested in this Marten document store, kind of doc, it's the prefix, and bank account. Because we saved the bank account, it created the bank account table for us. And if we have a look into the table, we will see, okay, has an ID, it has some data, and it's obviously our serialized object from the bank account. And the ID is the same than the ID of the record. And it's just the data that we saved. We have last modified. There is a certain version. For the document store, the version is actually used for concurrency issues. For event sourcing, it's kind of different, but we will see this. And we also saved the .NET runtime type. So for actually deserializing our serialized object. Okay, so when I switch back, after saving our object, we can open a new session, a query session. So we only can query data. And with the load function and our ID, we can actually get the saved object. So the object should be loaded, $1,000, and the owner is John Doe, and that's correct. All right, so we actually, I think I don't execute the tests right here, but just for, we also can create a lot of objects at once. So we can save an array of something. We can use actually link. So what we get back here is an iMarten queryable, and it's implementing iQueryable, so we can use link. Not everything is supported from link, but there is an overview in the documentation what data types are actually supported. So we can call count, and of course count should be 5 because we inserted 5 bank accounts. And yeah, I just want to mention it. I'm using TUnit here, and TUnit offers some very nice features like tests that depend on other tests. So on the one test, we can create stuff, and then on the other test, we can reuse it actually. But we need some kind of mechanism to share the stuff, or there is a mechanism to share stuff. So it's really easy to imagine. You can imagine on one test, we create something, we put it in a bag, and on the other test, we just have a look in our bag, and we see, okay, there might be something in it. We expect to have this test to have inserted something with a key accounts, and so we get those 5 bank accounts shared to the next test. And yeah, some of the tests are using this, so I just want to mention it. So we get the accounts from the bag, we just get the IDs, and so we also can load many accounts when we just provide the IDs. Another functionality is we can also update, of course, some records. So when we get our bank account back, so we loaded it. So that's actually a record notation. We create a new object and we replace the balance with some more balance and save it. Then the balance is updated. And the last test is, okay, we also can use some more complex queries like where clauses. Not all the people used US dollars as currency, so we can just query those people who were using US dollars. Okay, so that's really just a high-level overview of a document store. So we saw, okay, Marten creates for us some kind of tables with a doc, and it serializes the data into JSON. Now I want to go one step further and have a look at event sourcing. And we already were talking about it. So event sourcing contains something like the events and our aggregate. So those things I want to share with you right now. So we have some events here. It's called the bank account events. It's an abstract record, and we just implement some concrete classes within there. So we can use it for our events. And I really love or like to use records with Marten because it's so easy to use. We maybe have a little bit of overhead because of the creation of new objects, but I really think it's easy to read and easy to use. So you will see maybe a lot of records. So our bank account record, it actually has an owner and some balance. But it also has 2 more properties, the ID and the version. And those are properties that that are populated by Marten itself. So when we have them implemented, Marten will populate it. Why do we have to have a JSON include? Because I want to prohibit consumers of this class or of this object to actually manipulate it. So I made this ID private. And JSON include we need because we're using system JSON text, and also Marten is using system JSON text, so we need to kind of handle some edge cases from time to time when something is not working. Also with enums, we need to tell JSON, if we want to save it as strings, we need to annotate it, of course. But there is actually more, because we saw in the presentation before, there are some events, and we actually need to apply these events to our aggregate. So when an event happens, how is our aggregate actually changing? And usually it's done with apply methods. But what is with the first event that creates our aggregate? We need to handle this specially. So we also have a static template method that is listening to the opened event. And when this event happened, it creates our new bank account object with a balance of 0 and the owner, and that is actually within the opened event. So the event is just looking like this. It has an owner and it has the preferred currency of our owner. The other events are pretty easy. So we just need to implement the apply methods, and we need to pass the events, and we need to handle it respectively. We need to update the balance. When we deposit money, of course, we can add the amount, and if we withdraw money, we can subtract the amount. And if we have like 5 events, we will just apply those events from first, second, third, and the state actually will change. I will make some breakpoints here so that we can actually see it. And we are switching to our events sourcing tests. So the first test is pretty straightforward. All we have is our document store again. So we just need to configure it. I just use some system text serialization for our enumeration for the currency actually. Then we can open the lightweight session. We need to care about IDs ourselves, but also Marten can, but I do it separately. And once we have our ID, we can instruct Marten to create a new event stream. So the stream is the all events together, and we can append events to the stream. So this operation allows us to create a stream and to already append some new events. And in this case, it's the opened event, and we deposit some money. Then after some time, we append a new event, so we withdraw some money. So after appending this event, we already have 3 different events for our bank account stream. And once we save the changes, we will see what's actually had happened. Okay, so just starting the test. Okay, so we got to this point. We just opened our stream and saved the changes with the events. So let's see what's in our database actually, because we already committed our transaction. And let's see what Marten created. So ES demo 1, event sourcing, and yeah. So we see we have actually more tables. Our stream. So if we have a look at our stream, it has a certain ID. That's the ID we were generating before with GUID, new GUID. It has a certain type bank account. It already has a version 3 because we appended 3 different events. We have a certain timestamp and a snapshot. We have a creation date, tenant, and archived. We also have another table for the events. So events and the stream, they are related to each other. And we see this here in the stream ID. It's the foreign key for an event to its stream. So that's how they are connected, actually. Each event gets its own ID and a sequence ID too. And each event knows what version it has actually been. Then the data, I hope you can read it. Then the data, so when we first created it, we had the opened event, and it saved the owner and the actual preferred currency. Then we had the second event. It was a deposited event. We saved some amount and some, so we saved the amount and also for the withdrawn event. And we also have the timestamp. So the timestamp is equal because it has been saved in the same transaction. And we have the CLR type, so for deserialization again. Okay. So that's again the add back pattern, let's say, or concept from TUnit, and we can reuse our created stream and do some other stuff. For example, we want to see the current state of our stream, of our aggregate. So Marten is offering us this function, aggregate stream, and it loads the events of a certain stream, actually of the bank account ID, and it will append all the events separately. So we should hit all the breakpoints that we were using before. So create bank account or open bank account is the first event. We are actually landing here and returning the new bank account. The second event has been a deposited event, so we can add money and then we can remove money. And at the end, we are getting our aggregate, and it has the actual current state of $50. And the owner is still John Smith, and it has version 3. Okay, so maybe you think, isn't it a costly experience to all the time recalculate the aggregate? And the answer is yes, it is. But there are, of course, some mechanisms how to deal with it, and it's called snapshot. So when we append an event, we actually can take a snapshot of our aggregate. We then can load it and apply just one event on top of this aggregate. So we just need to actually handle one new event. So we can register a snapshot of our bank account aggregate in our session, and Marten is handling us this for us. It also has a certain lifetime, and if we have to look at this, there are two different lifetimes, one async and one inline. It's basically inline is within the same transaction, and async it's asynchronously, of course. But as it is a snapshot, we should have the most recent snapshot of our aggregate actually to decide what we are doing with our new events. And I don't execute this example here, but what we see is, because we are reusing the snapshot, or we are reusing the stream. We don't have a snapshot yet, but we can recalculate our snapshot at any point in time, and therefore we can use rebuild single stream, and then we have our snapshot. And I'm just placing a breakpoint here so we can see it in the database how it will look like. T4. Okay, okay, okay. Okay. Switch back. And we have our bank account snapshot actually here. So now it's a snapshot, and it should have version 3. So when Marten wants to append a new event, now it actually loads the snapshot instead of aggregating all the events. There are some, it makes it easier for us. So Marten offers us some methods to make it easier for us to interact actually with those kind of scenarios. So we can just write to an aggregate, then we have a lambda of the stream, and we can append one certain new event, and it actually gets appended. Marten will handle the loading of the snapshot for us, or if there is no snapshot at all, it just will append the new event. So we can then save it again, and so it's actually saved. I have a lot of examples, so maybe I just skip some of them, but you will get a link to this repository anyway, so if you're interested, you can still have a look at it. But maybe when we think about it, so we also can do some kind of time traveling. So we can ask our system, what was your state at a certain point in time? And I think that's a huge benefit for debugging. I heard of many companies who are using event sourcing in their production systems. They just need, the longest incident was about 4 hours, but that's just what I heard. So I think you can easily get to a state that a certain person had at that particular point in time. And so we can reconstruct what actually happened. Okay, so to the time traveling. It's just the same concept. We have a new stream. We have some events, and we have some task delays to have some time in between, so we can do some time traveling. And we just call save changes so that there are different timestamps. We add those timestamps to the bag. We grab it from the bag, and we just wanna see each point in time how was the state of that aggregate. So at the beginning we had, of course, a balance of 0 because it was just the bank account just was opened. And then we deposited some money, so we had 100. And after that, we had 150 because we deposited more, and even more, so we had 175. And just show this in the database. Okay, so we have our events saved in the database. They have different timestamps. And now we can do some time traveling. So we just saw, okay, it's just a searching part. So if we pass, we know it's true. Oh, sorry, just removing those breakpoints. All right, so at timestamp 1 it was 0, at timestamp 2 it was 100, and so on and so on. But we not only can do it with timestamps, we also can ask for certain versions. And what's a version? So when we append an event, it becomes a new version. And that's what we also can do. So we just want to aggregate our stream until a certain version. And so we can ask it again, the same questions. What was the balance at that point or at that version? And yeah, so that's actually it. I don't want to execute it right now because I think we are already far in the time. So, okay, optimistic concurrency. It's also an issue in event sourcing, because if two clients load the same state and they get a certain version, in this case, both get version 1. So client A and client B, they both hold version 1. And now it's kind of a race condition, who is faster with its command. Client A is sending some write operation and it manipulates, so it appends its event. And if we don't have some kind of check of the event, then we have maybe append an event that actually should not have been appended. So how is Marten doing this? We can send, or we should expose the versions to our clients and send it back to the backend, to Marten, and say, okay, this is the expected version for my event. And if in the meantime somebody other has written something, it just gets, it won't get appended. So I'm simply showing you how it will look in the code. Append events. Okay. So we can open two different sessions. And each session can append a new event. So in this case, session 1 is appending a new event, and we can pass the expected version. And if the version don't match, so also the second session is trying to append the version, so we get an exception from Marten, and it will refuse our intent. So, okay, the time is very far, but I want to show you two more concepts, maybe, or three, but not in the code, but in the slides. I prepared it, so it's pretty, I hope it will be a bit straightforward, so you can get to the beer because it's quite hot. But it's about the life cycle of projections. at what point in time do we calculate projections? Let's assume we have a stream and we want to append a new event. So the withdrawn event is not appended right now. We can open a transaction, and the easiest way is we do it live. So at this point in time, we close the transaction, we save our changes, and the event is actually saved. But the projection is live, and the live projection means we are just executing each command until we get to our projection. The second type of life cycle for projections is, we just, we close the transaction at this point in time, and we calculate we append the event and calculate the projection within the same transaction. So we can be pretty sure it will be saved. But there is a third option, and we were already talking a little bit about it. It's called an async projection. And when we save it here, so actually the event will be saved at this point in time, but then there is something like an async daemon, and it will run in the background, and when it has some free resources, it will care about updating the projections. So the projections will be updated after some amount of time, and we cannot guarantee that it's immediately updated. Then there are two different types of projections. There is a single stream projection. If we assume one event stream, we just can focus on our one stream and maybe get some new insights. So we already were talking about it, so maybe we want to count the deposits and withdrawals. But what if John, in this case, has actually two bank accounts, so we can also generate our projections from multiple streams. And in this case, it's two projections, or it's two streams from John. So John is actually highlighted. Why is that? Because we need to identify somehow related streams. You can also imagine some kind of user ID instead of John. So when we aggregate all of those events, we get some other insights. So John has actually two accounts, so we can maybe count it because of the bank account opened event. And it has, of course, a little bit more balance because he has two accounts and some more activity. Okay, so if you want to know how this works, I suggest the repository. You can just check it out and run it. There is a Docker Compose file. But I want to share some findings with you. So I found it quite interesting to have a concept that allows us to speak or translate the language of the business into our code. And not only into our code, but also save it down to the database. Otherwise, we just have our CRUD operations, but now we can really just save what happened in the real world. So we can also focus a little bit more on the business. And another huge benefit is so we can prepare for future questions. Maybe we don't know the questions of the future right now. The business is working with our software we created, but of course we want to gain insights, how people are using it, new statistics, some business decisions need to be made, and we easily can recreate new views of our data that we were collecting. We have a separation of read and write models. So writing is just appending events, and read models, they are already in our database ready to ship. We can rehydrate new read models on demand whenever we were asked from the business. It really fits CQRS because it's separating reads and writes, and also fits very good to vertical slice architecture. There was a talk I think two .NET Stammtischs before, and I tried it also in some sample application, and it really worked out pretty nice. There is actually some more tooling around Marten. So the creators of Marten, they create a whole stack, and it's called the Critter stack. So it's not only Marten, it can be combined with Wolverine, and Wolverine is a messaging library. So we can imagine Marten is handling the stuff inside of one service, but if we want to communicate maybe in our service, but also to the outside world, then Wolverine will support this heavily. But it does actually more because it maybe has to do something with the idea behind the Critter stack, because the Critter stack tries to make us focus more on the business stuff and not on the, they call it ceremony code. So don't write ceremony code, write the stuff that actually brings value to the business. And it's of course under active development and maintenance. I tried to make a pull request, and it was approved within 2 hours or something. So they are really behind this library. It's a little bit opinionated. So when we saw our aggregate, the bank account with the apply methods and the create methods, we have to know it. So Marten is actually doing this, I don't know, maybe with reflection, but I don't want to hold my hand into the fire for this. So it feels some kind of magic, but it also brings us a lot of support for example, dependency injection. So we can inject services in our methods, and it works out pretty nice. So that's one thing I liked. It's an alternative approach to CRUD. Of course, if you want to use it, you have to share the knowledge with your colleagues so that you're working on the same page. I think event and stream design is one important question, because we need to have a new look at the problem space, and we have to consider new concepts. And what if streams really get pretty long? So if we have many events, for example, the bank account, it can have many transactions. It's not pretty valuable. So there are concepts from accounting, and it's called close the books. So what they actually do is at the end of the month, they calculate the current balance, I would say. And from that point in time, they move on again to the next month and so on. So there are concepts you can deal with those kind of issues. Read models can be, of course, complex. It depends on what you actually need. So you maybe should consider to have less complexity in it, or argue for some less complexity. And of course, GDPR compliance, because we say facts and we cannot erase facts from the past. So how do we deal with this? There are also different concepts. I just want to mention it. For example, crypto shredding. So we can decrypt a whole stream with a public key or with a private key. And once somebody wants to remove his data, we can just throw away this key, and we never can decrypt it again. There are also other concepts like using a separate table for user data, for example, and just have a reference to the user data, and whenever somebody wants to have deleted his data, delete it from the from this table. Another option is masking, so we can go back to events that we want to mask. For example, the bank account opened event, we want to erase the name, we can actually do it. But there are also drawbacks, because what about the projections that are already hydrated with the name? So we need to take care about this. And that's really the last point. Thanks a lot. I hope you enjoyed it and maybe take some new inspiration. And yeah, if you want to check out the repository, that's the link to the repository. Thank you. Questions?
The aggregates, can they have some kind of, I call it now, parameter? For example, you had the example with the balance. Can I say, okay, I not only want to balance the overall balance, but I want a balance per, let's say, spanned category. You know, when the user with the transaction enters some category of spending or something like that, and then I want a balance, I want different balances, so aggregates, more than one aggregate, but which is dynamically created.
So not only one aggregate, but more aggregates of the same stream? Yes. Actually, I don't know. I only saw examples with one aggregate. So because we need to make some business decisions on the current state, but maybe you can do it with having a projection that delivers that particular information that you're interested in.
First of all, thank you very much for your talk. I have a question: why should I use a relational database and use a third-party tool instead of using an event store like DB or any other NoSQL database, for example? So.
Yeah, I didn't actually use it in production, so I don't know it. I'm quite interested or on fire to use it, so I cannot tell you from real practical work right now. But whenever you have, and I think you should maybe focus on the really important parts of the domain. So maybe of the core domain of the business. You maybe want to get some new insights in the future, so you can really benefit from when you have the whole record, how you got to the current state, if new questions come up. And maybe of the surrounding subdomains that just supporting the stuff, maybe it's not so important, so you can use still CRUD or the usual approach.
Do you suggest to use a mix of event sourcing with Marten and using a normal relational database like we usually do in our day-to-day business?
From my point of view, yes, of course, because I'm also new to this stuff, and I would start with something I can easily control, and I would not start to spread it all over the business. So there is also some onboarding time that you need to consider and to get familiar with the new tooling.
You mentioned optimistic locking. Does Marten also use transactions of the database itself, or does it solely rely on optimistic locking?
I don't know actually, I'm sorry, but I think it's on the documentation site. Any other questions?
All right, if there are no more questions, I'm going to hand over again. First, Christoph, we got you a small little present. Thank you for being a speaker here tonight. Please give a big round of applause.